today's conference. At that time, you may press star 1 on your touchtone phone to ask a question. I would now like to turn the call over to Ms. Janice Miller. Thank you, ma'am. You may begin.
Thank you so much. Hello, everyone, and thank you for joining us today for our Autodesk Educator Free Webinar Series. So, my name is Janice Miller, and I am the Education Program Manager for the Manufacturing Group within Autodesk. So today, I'd like to introduce today's webinar, and the title of our webinar is Integrating Computer-Aided Engineering, or CAE, tools into existing engineering courses. As you can tell by the title, today's presentation will emphasize the integration of CAE tools into existing engineering courses in order to enhance your course curricula. So what we'll be showing to you today, you'll see there are going to be some workshop modules. They will address the theory, numerical methods, and the application of engineering concepts within the context of Autodesk simulation and analysis solutions. So today we'll have two speakers. Myself will start you off, and then I will hand it over to Dr. Robert LeMaster. And Robert is a professor in the Department of Engineering at the University of Tennessee at Martin. So we'll be your two speakers today. So for myself, just to give you a quick background and kind of where I come from, as Education Program Manager here at Autodesk, what I do is I work to develop scalable programs while really listening very keenly to the needs and challenges that students and faculty such as yourself face today, and to listen to your needs and develop solutions to help out. So prior to coming to Autodesk, I actually developed custom training programs for partnerships with folks from Boeing, Lockheed Martin, NASA, Herman Miller, Disney, and several other corporations. And so early in my career, in addition to kind of my training experience, I also spent 4 years teaching, and I was in the Department of Telecommunications at Michigan State University. So I have experience in the teaching realm, just the same as you guys. So I really, again, really pay attention to what you're saying or what you're telling us as faculty, and that'll be what you'll see us showing you here today, as you'll see in a second. So our guest speaker, Dr. Robert LeMaster, he's a professor at the University of Tennessee at Martin, and here he teaches undergraduate mechanical engineering courses in machine design, mechanics, and CAE. So Bob received his BS in mechanical engineering from the University of Akron, his MS in engineering mechanics from the Ohio State University, and his PhD in engineering from the University of Tennessee. So prior to entering academia, Dr. LeMaster spent 20 years in the aerospace industry, and he held positions ranging from entry-level engineer to department manager. He has extensive experience in the development and application of computational software. He's also published numerous papers on both educational and technical topics, and has received several teaching awards. He's a registered engineer and is the owner of Mechanical Simulation Services, which is a consulting firm that specializes in the application of finite element technology. So without further delay, I would like to begin by going over the agenda for today's webinar and what you'll see with us. So if we look at the agenda, we're going to start here with an introduction. So we're going to introduce you to the Autodesk Simulation Workshop and what motivated it. Why did we create this? We'll then go into a content overview so we can explore that, and we'll show you what exactly is contained in the simulation workshop. That's when I'll then introduce Robert LeMaster, and I'll turn it over to him to show us how to integrate these modules into your existing curriculum. So we'll do a case study because he actually has taken some of this content and piloted it already in one of his courses. And then we'll go to next steps of adoption, collaboration, how you can get your hands on this material, and of course we'll have some room at the end for a live question and answer. So please hold your questions till the end. You can also use the online interface here with GoToMeeting to submit them online if you wish. So let's get started. So what exactly is the Autodesk Simulation Workshop? We held a focus group for mechanical engineering faculty, and that was here at Autodesk. This was back just about a year ago, so it was March of 2011. We invited faculty from North America and Europe, and we basically took 3 days and really did a lot of listening. We shut up and we listened. What are the challenges and needs that you are facing today as engineering faculty? And from the results, we got 4 really strong points. And the first 2 things were, what do you not want as faculty? We heard from faculty that you do not want complete curriculum from us. Reason being is you've already written your curriculum, and quite frankly, you put a lot of work into it, and it's probably pretty darn good. So you did not want complete curriculum. You also did not want tools-only training. I call it picks and clicks. In other words, you don't want just software training. Us to give you and say, okay, here's a piece of software, here's how you click this button to produce this result. But what did you want? What we heard was real-world examples. So how can we apply the software, and how can we get it to apply to what we're teaching in our classrooms? And also, you don't want complete curriculum, but you do want bite-sized nuggets of information to integrate into your curriculum. So in other words, taking modular content that you're able to then assemble and put into your existing curriculum to make it more exciting and engaging for your students. Okay? So, real quick, I want to show you where the simulation workshop fits in. So we have a bunch of learning resources that are available online and for free through the Autodesk Education community. Now, those of you on this call, many of you are probably members of the Autodesk Education community, and some of you may not have ever even heard of it. So if you haven't heard of it, go ahead and go to this link. It's www.autodesk.com/educommunity. And there you can actually get free access to training materials, to materials for yourself, to materials for your students, to exercises, to all sorts of information, and also download free software. And your students are available, or your students are able to download this free software to go ahead and use at home, whether they're working on labs or assignments or just tinkering around. You can also use it for your own training purposes as well. So I encourage you to go look at the education community. Unfortunately, in the interest of time, I can't really go through everything that's on there right now. But to show you where the Autodesk Simulation Workshop fits in, there's other workshops on the education community, including a BIM workshop, a sustainability workshop, and a digital STEAM workshop. That one's more for the K-12 secondary audience. But you'll see all of this accessible on the community itself. So now that you know where it is, what exactly is in it? So within the simulation workshop, first of all, it is a series of adaptable modules that connect the foundational concepts to the underlying theory that's illustrated with Autodesk software. So again, this is really going into your mechanical engineering courses, and we really want to connect the hows and the whys. So the content, you can find classroom PowerPoints, instructor notes, video modules, and data set files that go within each of these packets of content. And then you as faculty, you get to determine how do you integrate these into your curriculum. You can add real-world case studies, and in an ideal world, as this project grows and develops, we like to get a collaborative environment where faculty are actually sharing their experiences in real-world case studies with each other so we can build kind of a library. So that's not available yet, but that's a hope that we can potentially add that in the future. So looking at the different elements of the simulation workshop, okay, you look at the PowerPoint slides. These PowerPoint slides are meant for you to use as classroom use that you can go ahead and show your students. These involve the theory, the numerical methods, and the basic knowledge. There's also included instructor notes, what we call instructor notes. These can also be used, honestly, as student handouts if you wish. That's, again, up to you. These are explanations and detailed step-by-step if that's required. If there's exercises or examples that require detailed steps, those are also included in your instructor notes, along with additional information that'll help you with the module. The video modules themselves, these illustrate the implementation of theory, how-to examples. They address specific topics, and these videos are around 5 to 8 minutes in length. Again, they're very short and digestible on very specific topics. And then there's data set files. For exercises that require the use of CAD models, data sets, or archive files, we provide those to you. And then your contribution is really how, again, to integrate these, what we're calling learning nuggets, or modular information, into your curricula. And then adding the case studies, which, again, we really hope to develop a library of that and to get some collaboration between all of us. So you're kind of getting an idea of really what's involved here. And another thing to really point out to you is why is this valuable to you, and why the heck would you want to use it in the first place, right? So it's really key to point out that this was developed, this material was developed by faculty for faculty. This was not developed by Autodesk. Now, of course, as Autodesk, I was actually the project lead on this, and I obviously went out and monitored the development and made sure it hit our quality standards and went through approval. But as far as the creation, that's all created by faculty. So it's created by your peers, number one. So number two, it really focuses on the theories and methodologies and not the tool. So The Autodesk software is used to illustrate the hows and the whys. So you have your students that they're faced with these complex equations, right? Especially in the first 2 years, they're really hit with a lot of heavy math, heavy physics. So what this does is it takes the theories and methodologies behind that and it connects it in a manner that they can go ahead and see illustrated through videos and movement to see how it is applied. So it answers kind of the hows and the whys. The software connects the hand calculations to the demos. So say they're plugging in a certain number into one of those hand calculations. Well, why are they plugging in that number? First of all, why do you even choose that number? And what results does that have if you're changing that number in one of these equations? So a lot of the demos that are in the videos that you see are exploring exactly that. It's a what-if scenario. The gap analysis that was performed during our focus group. So again, this goes back to the faculty focus group that we held back in March of last year. The gap analysis was, what content do you need from us as a priority? And it was just loud and clear. Everyone said simulation. We need simulation. There's other gaps, which we hope to address in the future. But for now, what we focused on was the very, very most important one, which was simulation content. We hope that this resonates with many of you here on the phone. Simulation tools are also used across the entire engineering curriculum. So we heard this gap from faculty. We also then went and looked at kind of, our own software and said, well, what makes the most sense from what we heard? Well, it turns out faculty were 100% right. And the really cool thing is, our simulation applications can be used across the entire engineering curriculum, not just in the first years where you're doing maybe some basic, geometry or CAD modeling, and then coming back into capstone 4 years later. It's really used across the entire engineering curriculum. So to give you an example of that, we take a typical engineering curriculum, mechanical engineering curriculum. This was taken from the University of Wisconsin-Madison, just as an example, looking at your 200 through 400 courses. And if you look at the different courses we've got plugged in here, I'm going to put up an overlay and overlaying on how you can use our interactive tools to make the material more engaging and where it fits. So a lot of this simulation, software packages that we have really, again, span that entire curriculum. So you're able to plug this in at all different places to keep your students engaged and keep the content exciting. Okay? So to preview the material that's involved here is there's a preview site that's up now, and this actually hasn't officially launched. It won't officially launch until the end of this month, the very end of this month, like April 30th. But right now, because you're on this webinar, you can actually go to the preview site, and it is live. So we're offering that to folks who've expressed a keen interest in that, to explore it, to give us feedback, to tell us, how does it look? Are we going in the right direction? So there is a preview site that's live. Again, it's www.autodesk.com/simulation workshop. So within here, what you'll find is 6 sections. So these are the 6 sections we identified, again, from our content gap analysis. The 6 sections are working with imported geometry, linear material analysis, nonlinear material analysis, dynamic simulation, fluid flow, and thermal analysis. So right now, you'll see some of the sites, the content is up, some of the sites, the material is still being posted. So you'll also see some coming soon, some placeholders there. Again, it's the preview site. Within each of those 6 sections that you see, there are 5 to 10 modules. So here's an example of a module page. And within each different module, there are contained videos, instructor notes, the classroom PowerPoints, and the data sets. So those are all of the elements that I went over in previous slides. Those are in each module page. So this is not per section, this is per module. All of this is involved, okay? So within each of the 6 sections, you have 5 to 10 modules per section. And then you drill down to the videos. So I put an example of one of the video pages. And again, the videos are about average 5 to 8 minutes in length. These videos can be played out online, just in the viewer, or you can download them to play them at any time separately if you want to download and save that. All the material is able to be downloaded and saved. And some of the modules have 1 video, some have 4. Typically it's about 1 or 2, but some of the more kind of meatier topics, they have some multiple videos. So those are the examples of what's all included. So hopefully it kind of is really starting to give you a picture of the breadth and depth of this information. And hopefully some of the gears are starting to turn in your head of how you may be able to use this within your own curriculum. So to get the gears to turn even more, and to really give you a concrete example of how you can use this in your own curriculum, to take this modular content and incorporate it, this is where I'm going to turn it over to our guest speaker, Dr. Robert Lemaster. and he is going to go ahead and walk you through how he integrated one of these sections into his actual course. So without further ado, Bob, I'm going to turn the call over to you.
Okay, thank you, Janice. We can go to the next slide, please. Okay, the case study that I'll be talking about today is for a course called Kinematics and Dynamics of Machinery. It's a 400-level course offered in our mechanical engineering curriculum. It's a senior-level course. Consists of 3 one-hour lectures and 1 3-hour lab each week. The course content that is offered in this type of course includes gearing, cams, flywheels, balancing, and then mechanisms. And it is the mechanisms portion of the course that we'll be talking about today. Okay. In a traditional mechanisms course, you use vector-based methods to determine position, velocity, acceleration, and force. These vector-based equations have been used for many, many years. And when I was in school a long time ago, we used these, and we used T-squares and drafting boards and so forth to solve them graphically. Nowadays, they're still solved graphically, but we've progressed to such things as AutoCAD or the sketch environment inside of Autodesk Inventor. You can also use graphical methods with instant centers that give you another method for finding velocities in a mechanism. One of the problems that you have with teaching students to apply these is that these equations are applied at a particular instant of time. And so to see a mechanism actually move, they have to solve these set of equations multiple times, then plot the results in something like Excel, and then you can see things as a function of time. Next slide, please. In today's technology, the multi-body dynamics programs are commonly available. Autodesk simulation environment within the Inventor program is an example of this. They're integrated directly into the CAD modeling programs, and most of the students nowadays are taught how to develop 3D models, and so it's a natural progression into these types of programs. Practicing engineers need to understand the fundamental concepts of these methods because more than likely, if they're working with a mechanism out in industry, they will be using a multi-body dynamics program during the design process. The theory and methods are typically taught in graduate school for a multi-body dynamics program, and then depending on where you go to school, you may or may not actually see it. Okay. The challenge then is how to incorporate multi-body dynamics content into an undergraduate curriculum, and while at the same time still covering traditional course content. I believe that traditional course content is important. It provides insight into fundamental principles, and it's needed for licensure exams and other traditional activities that rely on manual methods. On the downside of traditional methods, though, they focus on a single instant of time, and students studying mechanisms never get to see anything move. And it's hard then for them to realize how the analytical methods that they're learning actually apply to something that they can't see move. So being able to visualize the motion is something that's very important in the study of mechanisms. Okay? In trying to integrate new content into a course, it's important that you build on the things that the students have previously been exposed to. In the case of mechanisms, so a central theme is the concept of constraints. Constraints are applied in the traditional method through the vector loop equations or the vector equations that describe the motion. On the other hand, constraints are also used in the multi-body dynamic programs. It is this consistency of the concept of constraints that allows this material to be easily integrated, and that you can start by introducing the traditional content with an emphasis on the concept of constraints and how they control the motion. And then as you build, you just come up with different ways of writing the constraints. In the case of the traditional methods are primarily vector constraints. In the case of the multi-body dynamics programs, they're typically algebraic constraints. The integration of the material, I basically continue to teach the traditional graphics-based methods, but I do that in the lab portion of the course only. Whereas with the multi-body dynamic content, the lecture material is used to present the theory and the basic knowledge associated with it, while the labs are spent then trying to tie together how the theory relates to a modern piece of software that then implements that theory. In the modern portion of the course, I use both the videos, PowerPoint, and data sets that are available in the total course. For instance, the videos are used during the assignment phase so students can see what content is going to be used in the lab. The PowerPoint lecture material is used to supplement the lectures, and then the data sets are also used in the lab exercises. Next slide, please. The lecture content introduces a number of different topics. Starts out with rigid body degrees of freedom, and this applies both to the traditional and more modern approach. Joints and degrees of freedom, how the joints affect the number of degrees of freedom of the mechanism, and comes up with the concept of mobility and joint constraints. How constraint equations are developed and written are studied, and there's two particular types of joints that are used extensively in planar mechanisms, and that would be a revolute joint and a prismatic joint. Next what I do is I take and develop those constraint equations into the kinematics. How do I determine the position, velocity, accelerations from the constraint equations, then leading that into Lagrange's equations and Lagrangian multipliers, which are used in conjunction with the constraint equations to determine the forces acting on the joints. Finally, putting all these equations together into a matrix form that illustrate both the coupled differential algebraic equations and the very nature of these types of equations. Again, the PowerPoint slides are used to explain the theory, numerical methods, and basic knowledge. In this particular slide that you see on the inset, there talks about a revolute joint and how two planar components are connected in that manner. Okay, next slide. During the lab portion of the course, it is, as I mentioned earlier, divided into two parts. One that deals with the traditional content, and then a latter portion which is concerned with the modern content. There are other things that we do with the lab. The labs that are associated with mechanisms take up 7 of approximately 13 or 14 of the total number of labs. During the traditional portion, labs 1 through 4, we focus on using the graphical-based methods to solve the vector equations to determine position, velocity, instant centers, and relative acceleration. We use the sketch environment within Autodesk Inventor to do this, and the Inventor environment is very good in that it forces the students to start thinking in terms of constraints as they assemble the stick figures that are used in the traditional approach by applying constraints at their joints. They're already used to doing that, so when we start doing the multi-body dynamic simulation portion, it's a natural extension then to the writing and studying the actual equations that are implemented at these joints. In the modern content portion, we use all the content that's been developed through Autodesk, including the videos, the PowerPoint, and the data sets, and we use the dynamic simulation environment in Autodesk Inventor as the piece of software to show how one of the programs that uses this theory operates. I'll have Janice start up a video now that gives an idea of how one of these examples are done.
Okay, so what I'll do here is I'll just start up a video, and we're just going to show you probably about 2 minutes of it, just to give you an idea of an example of one of these videos. Let me start it up here.
This video is associated with Module 6 that addresses Lagrange's equation of motion. The PowerPoint slides associated with this video provide theoretical information about this important equation.
Okay, so I'm going to skip ahead a little bit, just show you kind of a little bit of the intro.
Apply a joint torque. We must have the enabled joint torque box selected. We'll apply a torque of 1200 Newton per Newton millimeters. Once we have applied the torque, then we are able to run the analysis. We will again use the 0.051 second duration that was used earlier, and we'll continue to use the 540 capture rate that was used previously. Select the forward arrow to run the simulation. If you watch closely during the simulation, you can see that the speed of the camshaft in this case varies. When we did the kinematic analysis, it was a constant motion. In this case, the torque is constant and the speed will vary. We will see this more clearly when we plot the results using the output grapher. The analysis is complete, and we'll look at the results. We can expand the browser items in the output grapher, and we can see now the standard joints and the force joints. We are interested in a revolution joint, and notice that we can plot positions, velocities, accelerations, or the force and moments applied. We'll first look at the moment that was applied, and we'll look at the moment about the z-axis, which is the rotational axis of the revolution joint. Notice that we have a constant value of 1200 Newton millimeters, which is what we applied in the analysis setup. Next, we will look at the velocity, and we'll look at the angular velocity, which is the only one available. The velocity looks more like a sawtooth, and it starts out slowly and speeds up to a steady state value. This is typical of a dynamic analysis as opposed to a kinematic analysis. If you recall, when we imposed the constant angular motion in the kinematic analysis, we had a constant velocity. We have now a constant torque, but we have a variable velocity. This distinction is very subtle, but very important to someone designing equipment, and they have to make sure that they are getting the results that they want. This concludes this video.
Okay, there was just an example. So, Bob, back to you.
Okay, have the next slide, please. Okay, in integrating the videos and data sets and so forth into the lab, what I did was I used the videos as a pre-lab assignment. So on the Lab 5, for example, which consists of joint constraints and mobility, there were 5 videos that dealt with that topic, videos 1, 2, 3, 5A, and 5B. I assigned those to be viewed by the students prior to coming to the lab. The videos were made available via Blackboard, and then when they show up to lab, they already have a pretty good idea of the topics and the things that we're going to be doing in lab. We then use the data sets that are available associated with those videos. It enables us to very quickly get into the topic that we're wanting to discuss. In doing multi-body dynamic simulations, you have to start with a mechanism and typically as an assembly. Now that assembly, if you were to try to develop it as part of the lab, you would spend all the time having students model and then get the assembly constraints and everything set up, and they would probably run out of time and not have any time to spend doing the exercise that you really want them to do. So the data sets are very good in that they provide you a starting point in which all the models and everything needed to do the particular lab is available at the onset. The other two labs, Lab 6 and Lab 7, then do the same thing, starting with videos as pre-lab assignments, and then as they progress from doing a kinematic analysis in which a motion is specified to start the mechanism to move versus a force which is used in Lab 7. One of the things that I observed as the course progressed is as the students became familiar with looking at the videos prior to the lab, that in some cases they would come to the lab with the exercise already complete. They would be sitting in one of our computer labs looking at the video and then doing the exercise as we went, whereas they watched the video and by the time they came to the lab they had everything done. And I thought that was a good example of how this type of thing can motivate students to learn on their own. Could I have the next slide, please? The outcomes associated with the mechanisms portion of this course is a mixture of the historical mechanism content and that associated with multi-body dynamics. They are able to determine the mobility of a mechanism. This is certainly applicable both traditional and the multi-body dynamics approach. They're able to derive the traditional relative motion kinematic equations. My experience has been that if they can derive the equations, they have a much better shot at being able to solve them without getting tangled up in all the different cross products and so forth that are required. They then have to be able to apply those traditional equations to find the motion, except position, velocity, accelerations, etc., for a planar mechanism. Then steps 4 through 7, or outcomes 4 through 7, are associated with the multi-body content. They have to be able to write kinematic constraint equations for a planar mechanism that have revolute joints. They are able to have to be able to find the Jacobian of a set of constraint equations. Jacobian is a central item that's used in the solution of these equations, and the only way to really understand what the Jacobian is to be able to take a set of constraint equations and find it. The next is to describe the difference between a kinematic and multi-dynamic multi-body analysis. Kinematic and dynamic analyses are fundamentally different, and it's important for students to understand the distinct difference so that when they're trying to solve a problem, they know which approach to take. And then they have to be able to perform a kinematic or dynamic analysis using a multi-body simulation program. Okay, next slide, please. In summary, we started out with a challenge that it's often difficult to incorporate modern technology into courses while still covering traditional methods. And in this particular case study, an example has been provided that shows how an introduction to multi-body dynamics was incorporated into a traditional kinematics and dynamics machines course. One of the elements of this type of course is that they typically have a lab, and that lab is used to do the graphic solution. So it was able to easy to extend the content into the lab and use the more modern software. Students continue to study traditional methods, and they do this while gaining a deeper and more thorough understanding of how mechanisms behave. I think this is obtained through the concept of constraints and realizing that the difference between many mechanisms is just how they're constrained. And the ability to see the things move is an important part of this. The multi-body dynamic simulation programs, they can model them up, apply either motions as a function of time or forces as a function of time, and see things move. If they have the constraints applied incorrectly, they see that they move differently than what they wanted. And by correcting that and seeing the effect that the constraints have, again, it enforces this central And then finally, having some students to use the videos to accomplish lab assignments prior to coming to lab, I thought was a real testament to the value of this approach. Next slide.
There we go. That's it. Well, thank you so much, Dr. Robert Lemaster, for sharing that with us. And another thing to say before I get into the timeline here from this site is that Bob also is one of our content creators. He created one of our sections, and I wanted to say just some real quick words on how we selected folks to create this stuff. So we really put on a very extensive search to faculty who were really not only experts in this material, but actively teaching it. And as you can see with Bob here, we made a wonderful choice because he now has developed content that fits into curriculum that he's actively teaching, and seeing results of his students getting motivated, taking this work, learning it on their own, understanding things more. It's just, it's a testament to this type of content. And that's what really keeps me going as I was leading this project, is seeing the inspiration that it sparks in our students, right? Because they're our future engineers. We want to keep them motivated. So our hope is that this content will help inspire our next generation of engineering students. So with that, the timeline for the deployment of this. So all content here is made public, and only the data sets are protected through the education community. So I mentioned the Autodesk education community at the beginning of this call as a source you can log in for free software and training and resources and these workshops. So when I say protected, all I mean is that sits on the education community where you need to register to get those data sets. And with registering, it isn't this, we don't send you spam or any of this stuff like that. It's simply a way to access that portal to get access to the free content. So that hopefully is not a barrier for you. We polled our focus group, and they didn't find that as a hindrance, so we hope that you're the same as that. Because the best thing to remember here is not only do you get access to this, the data sets for this particular workshop, but you get access to everything that's on that community, especially that free software to download, and the rest of the workshop besides just the simulation workshop. So there's a hard launch of this website at the end of this month, April 30th, like I said at the beginning of this call. But as I mentioned before, we're doing a special preview launch. We did a webinar with ASCE about 3 weeks ago. We did that first. And then we did this as a follow-up to that, because a lot of the folks that attended this ASCE webinar that you see on here, which is the same thing that we've presented to you today, they said, well, they had colleagues who were not able to attend that, so they asked us if we would do it again, and we said absolutely. So now we've done it through this educator series with Autodesk. So the preview launch is also for you. You do not have to be a member of ASWE to preview this. Any of you on this call can preview this right now. It is live. And note that the section content is still being added to the preview site. Okay, so you'll see some coming soon placeholders. So just realize that we'll post content as soon as it's done. We're wrapping up to the very end here, but we've still got a couple different packaging and approvals to go through. But 3 of the 6 sections are up, with the rest of them being added fairly quickly. So we really encourage you, explore this site and let us know what you think. We've had, one faculty found one of the videos didn't play in a certain browser. Even things like that. Again, this is a preview site, so now is the time to find those bugs. But by and large, folks have been pretty happy with it. But if you do find anything, whether it's quirk in the site or whether it's just a thought that you have, you think the content is great, you think the content is not enough, whichever. We like to hear both sides. So don't hold back on your feedback. We want to hear all the positives. We also want to hear the negatives. How do you think we're doing with this? Because that helps us to move forward and to improve this. So please take advantage of this preview site before the launch, and just do some digging around. Let us know what you think there. So the next steps, obviously, your partnership and your cooperation is really the key to the success of our future engineering workforce. Okay, so you are the experts. We here at Autodesk, we're not. We're providing you the tools. We're providing you the content to make this material more exciting for your students. But it's you who are the key to this. You're the ones that are going to be teaching this and go ahead and getting the students engaged. So if you're very excited about what you saw here today and what you heard from Dr. Bob Lemaster and what you heard and saw from the content that I showed you, we hope that it resonates with you the same as it resonated with our faculty focus group. And if you're interested in piloting this content in your courses, we've got a couple different things here. Obviously, you can go ahead and explore the website. we're also going to be having some physical media. These are external contact hard drives. These are kind of cool. They're little silver drives with our Autodesk logo on it. We're going to have these available like early to mid-May. And what we're going to do is it's going to be the exact same content that you see on this preview site and when the site launches at the end of the month. It'll be the same content, but it'll all be on this external contact drive so that you have it all there in one spot. And for those willing to pilot the content, we can actually send you these drives. But this isn't just, a trial thing. We only have a limited number of drives, so you have to be interested in piloting it. And by pilot, all we mean is you agree to provide us feedback, quotes or testimonials, case studies, very much the same as you saw Dr. Bob Lemaster do here with us today, just so that we can start to build this library of how the faculty are using this. How can it help to really, help our engineering workforce to succeed? So to get on the list, if you would like to pilot this content or have feedback, please contact Matt Pierce. He is a colleague of mine who is within the education department here at Autodesk, and he is really in the manufacturing industry specialization as well. And so just chat him an email at this email address. It's just matt.pierce@autodesk.com. Just tell him, hey, I attended the webinar. I would love to sign up for the pilot. And when those physical drives are available, we will mail one to you. Make sure you provide him with your address, your mailing address for May. And again, the same content is available online. So if you're interested in having it all in one spot, so you don't have to, you can avoid all the downloading, we're absolutely happy to provide that to you. So just let us know, drop Nat a line, and we really hope that you're very, very excited and inspired by what you've seen here today. So I would like to thank Dr. Robert Lemaster for presenting how he's integrated this content into his particular curriculum. And I'd like to thank all of you for tuning in and listening and spending some time with us today. So we've got about 15 minutes left, and in that time, I would love to open it up for questions. We can open up questions on the phone, and we also have my colleague Gary is standing by with any questions that have come in online. So, operator, at this time, we would like to start the Q&A.
Thank you, and at this time, if anyone would like to ask a question, please press star 1 on your phone, unmute your phone, and record your name clearly when prompted. Again, for any questions, please press star 1. It'll take just a moment or so for any questions to come through.
Gary, while we're waiting for the phone questions, did you get any questions that came in online during the webinar?
I have no questions currently through the questions section in the webinar, Janice.
Okay. So again, if you want to ask your questions over the phone, if you don't, you can go ahead and on your GoToWebinar online, your little interface panel, there's a little space there you can type a message. If you would prefer to remain anonymous for whatever reason, you can go ahead and type your message in there.
We do have a question on the phone from Al Jonikin. Go ahead, your line is up.
Yes, I'm with the secondary level school districts, but we have articulations with 2-year and 4-year colleges. What suggestions would you have for us in particular preparing these kids early on for this exciting journey?
Well, that's actually that's a wonderful question, and we have an entire team here at Autodesk that's involved in the secondary level, and we are talking about this very thing of how to go ahead and kind of, as you're saying, get them ready or bridge that gap and kind of get them geared up for this, because this content obviously is a little bit more into the first and second years of college here and spans that curriculum. So actually, what I would really be very interested is in following up with you and connecting you with our secondary team. If you could go ahead and provide us with your contact information, I would be absolutely very, very happy to follow up with you.
That's great. Would you then take a moment and slowly give me your information? I got into this thing late, and it did not messing up here.
Okay, sure. If you want to go ahead and you can email me directly. And my name is Janice Miller. My email is very simple. It's Janice, Jan, as in Nancy, ICE, dot Miller, MILLER, at Autodesk.com. And that's just our company, AUTODESK. You can see it right here on the slide.
Oh, yes.
So it's Janice.Miller at Autodesk.com. And I will absolutely connect you with the right folks on our team. It's a wonderful question and something that's definitely very, very front of our minds is bridging that gap.
Great. I'll do that right away.
Wonderful, thank you.
Is there a number? Is there a phone number?
Well, I'm trying to see. Probably, I've got several different numbers here. Trying to think which one would be the best here. Is that, I would probably say, you know what, probably just my work line because it has it's constantly answered. Go ahead, that number is 248, and this goes to anyone else on the call as well. Feel free to call as well as email. So the number is 248-449-2254. 248-449-2254.
Thank you. I'll get off and let someone help us. Yeah.
Absolutely. And then again, for the rest of you on this call here, if you're interested in piloting this content, again, if you're at the post-secondary level, you can contact my colleague Matt Pierce, and that's similar format as my email, matt.pierce@autodesk.com. Between him and myself, we'll be very happy to get you hooked up with the right.
P-I-E-R-C-E?
Yep, P-I-E-R-C-E.
M-A-T-T.
You got it.
Thank you.
You're very welcome.
Our next question is from Matt John. Go ahead, your line is open.
Yes, I have a question.
Oh, one moment.
Sounds like we lost him. Show the Matt.
Matt, go ahead, your line is open again. Please start again with your question. Thank you.
Okay. Hi, how are you doing? My question is, the simulation software I just watched is a part of Inventor.
So what you've seen demoed here, this is a simulation environment, inside of Autodesk Inventor. Yeah, so it's basically the one that's demoed. Most of the stuff you see is simulation multi-physics. There's also a new package out that's this year that is CFD, and so that's a standalone package right there. But you're not seeing CFD here. In here, you're seeing the simulation environment inside Autodesk Inventor. Yes, correct.
Thank you.
Our next question is from Larry Enright. Go ahead, your line is open.
Yeah, I'm just at a junior high or senior high level. So this curriculum is for post-secondary. Can you help me with that? Is that correct?
Oh, sure. Yeah, this curriculum is really, the audience is really looking at first and second year students that are in college, so in the graduate or the post-secondary level. As we showed you, it spans across the entire curriculum. However, keeping that in mind, I don't want to limit you or anyone on this call, like the first gentleman that called in at the secondary level, I don't want to limit you to say that you cannot use this. You absolutely can use this material at the high school level. We are working on here at Autodesk, kind of I guess you could call it a version, to see how to fit this into the more of the junior high level there. That's something that we have not developed yet. But in saying that, I don't want you to limit yourself. So if you have ideas or you're looking at this content and you're saying, gosh, I teach mechanical engineering at a high school, I teach a CAD class, and I think this absolutely could fit in, we would be absolutely very, very interested to talk with you about that. We actually have one professor that we met at our conference that we had here in March, and he came in, he's teaching at a school out west, and he wants to work with us to go ahead and start integrating this content at a high school level because he has courses where it does fit in, and that's before college. So, yes, we would be very interested. What we've presented to you here today is aimed at college, but that doesn't mean that it can't be applied to the high school level students. So if you're interested in talking more with us about that, again, please contact us. That's kind of what this webinar is all about. I'm really happy to hear the first question and your question that were asked, because this webinar is really about not just piloting the content, but getting this collaboration and this partnership formed. So if you're interested, we'd love to talk to you about that.
Okay, thank you.
Yes, thank you very much.
And we are showing no further questions on the phone.
Janice, I do have some that have come in through GoToWebinar. So the first one here, I think addresses the point that we just heard from the gentleman, is does Autodesk offer any similar material for high school curriculum like Project Lead the Way?
Yep, that's what the hopes are. So this was kind of the first type of content within simulation that you'll see, and the first audience that we've targeted here. But yes, as you've heard me say, to the two previous gentlemen, is our hope is absolutely bring this to the secondary level, which is more the junior high, the high school level. We've also got some cool products that are out, and one of them is an iPad application called Force Effect. And I'm not sure if any of you on the call have seen that, but that will be part of how we can bridge that gap and take this into high school and even younger than that, because Force Effect is an application that basically allows you to apply, forces, motions, and torques just all on the iPad. It's very quick, very, very simple, and we're thinking about building this, using this as one of the bridges to build into this particular content, which is at a little bit more of a complex level. So you will absolutely see a lot of movement around the secondary level or the high school and junior high school level within this coming year, yes.
And another question here through GoToWebinar is that the simulation shown today, will that work with older versions of Inventor?
Older versions? Bob, do you have any idea of this question?
Actually, the version of Inventor that the simulation works with is a package of Inventor products known as Inventor Professional, and I believe that's the earliest that it's introduced. So I don't think it goes. I'm not sure exactly how far back it goes, but I do know you need the Autodesk Professional version of Inventor.
Okay, yeah, but now that you say that, it's triggering some questions I've heard before in my mind as far as the product itself is related. And that is correct, yes. So it's the Inventor Professional version. It's a very specific version that this is available in. And also, to add to that, if you have further software questions that are software specific or have to do with functionality or what's available, again, I'd be very, very happy to put you in contact with any one of our product experts. I'm not a product expert myself because I'm dealing with the educational curriculum. But if you would like to ask questions for a product expert, once again, use us as a resource. We can connect you directly to someone who can answer your direct questions if you have more specifics on functionality or what works where. So again, you can email my colleague Matt Pierce, who's on the screen, or you can contact myself. We'd be very, very happy to help you with that. If there's any technical questions that we can't quite answer here, absolutely. Do we have any other questions that came in online or on the phone?
No more questions online, Janice.
And I do not have any more questions on the phone.
Oh,
okay.
I do have one here.
Go ahead.
Let's see here. At a high school that has a Mac environment, is it available with the Mac or Apple?
Not at this moment. However, I can say that the application that I talked about, Force Effect, that's not what you're seeing here. That's not the Autodesk Simulation Workshop. The Autodesk Simulation Workshop right now is not an app per se, but the app called Force Effect, which is again quite scaled down, but it's a really cool program for the Mac environment. I would highly recommend checking out the app called Force Effect. It's gotten absolutely rave reviews. We're using it here all the time. It's fantastic. So it's not quite what you're seeing here, but it is a really, really cool thing for Apple users. As far as the Mac question, expanding into when will this be available for the Mac, that again will be a question for our product team. And once again, I would be happy to connect you with them because I do not have any specific answers about platforms or when it's available for what, and we do not know that type of information. But if you would like to ask that specific question, my colleague Matt or myself would be happy to again point you in the right direction to ask those more directed questions.
And I did get a question on the phone. We have a question from Larry Emmert. Go ahead, your line is open.
Hey, sorry, I messed up because obviously when I was punching in my name and all, I had the question about the Mac environment, so you answered it. Thank you.
Oh, excellent. Not a problem. So yeah, Matt or myself an email will be happy to hook you up with the folks who can talk more about the production and development.
Thank you.
Sure.
Janice, could I add a comment?
Absolutely.
There's been several questions about whether this is available for high school or junior high type applications. And one of the things we get a lot of times at the college level is that students really come in and they don't know what engineers do. They don't know what engineering's about. they think it might be working on cars versus designing cars or whatever. And one of the things I think these videos are good for is that they can be shown in maybe physics classes or even by guidance counselors, and to give students an idea of the kinds of problems and the kinds of things that engineers that are get involved with on a day-to-day basis. And certainly understanding how mechanisms and things move and work, they can visualize that, even though they may not appreciate yet the mathematics and so forth that are involved. They certainly can see the videos and some of the discussion and things that an engineer has to deal with. So I think they're very good for trying to educate young people as to maybe what engineering is about.
That's fantastic. Thank you for that addition. And that's absolutely, again, very much a part of what our Autodesk secondary team is working on is, what type of messaging can we put out there, and what types of materials for guidance counselors, and for teachers and for students of this age to show. So I think that's great. I'm going to take all these ideas back to our team and really, start executing on this, start figuring out what's the best way to appeal to the secondary students. And this is fantastic. This feedback just from those of you who have called in with questions just on this call has been wonderful, because it's just reinforcing what we already know is that, okay, we took this to college, we now need to take it to the younger generation. So I thank all of you for that. And Bob, thank you so much for the addition at the end here. And I think we're coming pretty much up against our time. And so with that, if you have further questions, again, please email my colleague Matt or myself. We're very, very happy to assist you there. And other than that, thank you so much for your participation. This has been a great interactive session. And I really, really appreciate you all tuning in. I hope you're as inspired as we are by the content here. So thank you so much.
And that does conclude today's conference. Thank you for participating.